Hi there, this is Joel at Earth Tools, and we're going to do a little maintenance video on sickle bar mowers for walk-behind tractors. What we've got here today is a BCS 53-inch single-action sickle bar. We're going to do a separate video on the maintenance of double-action sickle bars. Double action is when both teeth move. Single action is when just the upper teeth move. This is the more common sickle bar on the market, so this is the one we're doing first. We need a little maintenance on the blade on this thing, so we're going to be taking the blade off. To do that, we're going to remove the blade coupling in the center. The blade coupling is the part of the unit that couples the moving pitman arm coming off the gearbox to the actual blade. So this thing transfers the power between the pitman arm and the blade. U-shaped device. Now that that's off of there, we can loosen up our clamps. The clamps are holding the upper blades, which move, down against the lower blades, which don't move on this single action bar. We're just going to loosen up each one with these two big bolts here in the top. I want to point out that there is also on these clamps an adjustment bolt in the back of the clamp. The adjustment bolt is what you use to adjust the clamp as the blades wear. Basically, backing out this bolt down flexes the clamp forward and makes it pinch down harder on the top of the blade. You don't want to loosen these up to remove the blades, because then your adjustment will be all screwed up and you'll have to redo it when you put it back together. Just loosening up the entire clamp assemblies is the quick way to get it off without changing your adjustment. Retensioning the blades with these back bolts is something that you only do typically about once a year or every other year. So, we've loosened up those clamps. The clamps are now loose, and the blade. Notice I have gloves on. These things are sharp. We'll slide right out. I didn't bother cleaning this up because this is the way they get in the field, full of mud and grass and everything else. So this blade, I'm checking for loose teeth here. This blade actually hasn't been in service very long, and this one's still in pretty good shape. A little grinding to sharpen this will put this back in condition. We don't have a single loose blade. Now, each sickle bar comes with a complete replacement blade assembly. And the replacement blade for this particular sickle bar is lying over here. It was already switched out. This one does need a little service. It's got some loose teeth. Probably hear that. There's another loose one. Tight, 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 tight. Yeah, most of them are tight. One of them right in the center there is loose. And this one here, you may be able to see, is knocked at a pretty good angle, which means the rivets are nearly sheared off. I don't trust those rivets anymore. We're going to replace those rivets and probably replace that tooth while we're at it. So, number one thing is, how do you tighten loose teeth? Let's find those loose ones again. Okay, there's one that's loose. It's just a little bit loose, just barely moves on the rivets. I don't think there's any danger of this having the rivets sheared part way off. So we're just going to tighten those up. To tighten loose rivets on one of these things, what you're going to do is drive on the bottom of the rivet. This is the top of the blade, so this would be considered the top of the rivet. This is the bottom of the rivet. You're going to drive on the bottom of the rivet with the ball end of a ball-peen hammer. And we're going to come over here now to the vise. The back of this vise, like most vices, has an anvil on it. In fact, we might turn this thing around so we can get at the anvil a little better. What I'm going to do is identify that loose one. I want to support the heads of the rivets on the anvil, like so. And I'll use the ball end ball end is going to flare that steel out, and it's going to tighten the tooth up immediately. So those all look good. There's another loose one. Again, rivets aren't in real bad shape on that one. We'll just go ahead and tighten that. Sometimes you come into a place where you've got these little clean out tabs. These sit right under the blade clamps and they're supposed to clean the dirt out from under them. They only do a halfway job, but they're there. The fact is these rivets are obviously on two levels. You just have to take that into account when you're setting it on the vise. I'll have to use the corner of the vise here to get around that little tab. Right there. Okay, nice and tight. Now we come to the one that's all buggered up here. I don't trust this one. It's taking a very hard hit. So what I'm going to do is I'm going to have to drill those rivet heads off of there to get this thing out. I've got over here a drill and a center punch. A center punch is a punch that comes to a complete point at the end. And on mild steel like this, well, I'd best do this on the anvil actually. If you've got a little bit of a helper, some kind of a second hand, it makes life a little easier. So there's the bad one. Get that rivet on there. And what I'm going to do is try to punch a hole right in the center of that rivet so I've got a guide to drill into. Good. Punch mark there. Got that one a little off center. I can walk it a little bit. These rivets are kind of bent at a crazy angle because of the impact. Helps if you actually tighten the chuck of the vise first, or the drill chuck. Better. This one I have to... I'm using a 3/8 inch bit. You actually get away with one a little bigger. But the basic fact is you want to drill on the bottoms of these rivets instead of the tops. You could drill on the tops, but if I get into this bar too far, if I drill a little too far here and get past the rivet head, I'm going to be drilling into this strip, which is going to weaken the strip. If I drill in too far here, I'm getting into the tooth, and I'm going to replace that tooth anyway. This is disposable. So that's why I choose to drill on the bottom. Take these out just a little further. And we need a battery. Alright, we've got our battery changed in the drill. I drilled off the rest of these heads to where I could see that I was past most of the head and down to the actual diameter of the rivet. Now I'm going to drive these rivets out of here, or what's left of them, So I've got my handy helper here holding up the other end of this thing. Going to use a pin punch, 7/32 pin punch. This will be too big for some sickle bars. Some sickle bars use a slightly smaller rivet. On this particular bar, these are 6.3 diameter rivets, which is about 1/4 inch. So you want to use one size smaller punch. You don't want the punch size to be exactly the same as the rivet. It's very hard to get on the center of it. Some sickle bars use a 5.3 diameter rivet, which you'll go down to a 3/16 punch. I'm going to use a vice grips to hold the punch because I've been doing this long enough to know that you don't always hit the punch, and it hurts. So I'm going to center this up in here. Punch what's left of the rivet out. Done. That tooth probably is serviceable again, but it's taken such a big impact I don't trust it. It may crack. So we'll grab a steel brush. Get rid of any dirt and other material that might be there. Ready to put it back together. Alright, so for reassembly, I'm going to set my rivets down on the anvil. The bottom of the rivet already has a head on it that's tapered to fit into the countersink in the bottom of the teeth. And set like so. And of course I put it on backwards. So like that. Now, I should say at this point that some sickle bars, depending on the year they were manufactured, have this blade holding strip that holds all the teeth together on the top of the blades, like you see here, with the blades being riveted to the bottom of the strip. Earlier ones, ones manufactured back in the mid-90s, all the way back into the 70s and 80s from BCS, had the blades on top of the strip. So this assembly would be kind of reversed. But obviously the way yours is put together is the way you want to put it back together. The assembly is essentially the same. So now I'm going to drive these rivets down. And a ball peen hammer is a tool that was designed to drive rivets. A lot of people wonder what the ball end is for. Well, we talked about how earlier when you hit something with the ball, it actually mashes the steel out away from the striking surface. And both ends of the hammer are useful for rivets, and this is how it's intended to be used. Before I start this, I'll say you always want to select the appropriate length rivets. There are different length rivets for different applications. For example, the ones that pass through these little strips are slightly longer, as well as the ones that pass through this blade coupling strip in the center that the blade coupling bolts down to. These are longer rivets as well. So there's usually 2, sometimes 3 length rivets on these things. Also, I'll take the opportunity to say that before you order new teeth, don't just assume that a BCS sickle bar all takes the same teeth. There are actually 5 different tooth styles. And to find the tooth that you need, take something like a wire brush and scrape them away, and way down here under the rust and grime, you will see a number. This one says 50696, if you can see it in the right light, which is the tooth I've selected to replace it. So, now that I've lost one of my rivets, don't talk and rivet at the same time. Another one of the rules here that I'm violating today. So, hold this thing on there, and I'll start with the ball end. Whenever the ball strikes it, it's driving the steel of the rivet out away from the shank of the rivet. It's not really smashing the rivet down, it's compressing the steel, it's rolling the steel over, it's mushrooming it out. That's what you want for the beginning. You want a head to be mushroomed. You get the rivet about half driven down using the ball end, and then you flip it over and use the flat end of the hammer. When you hit it with the flat end of the hammer, the steel is no longer really going to mushroom too much. It's going to actually compress the entire shank of the rivet and swell it at the same time. And that'll take up this slop that you see here to actually tighten the rivet up in the hole. So making sure everything Everything is nice and firm. Tight as anything. And the rivets have swelled out and completely filled up the holes, as well as the mushroom tops coming down on there. And as you can see, there is no gap between the sickle blade and the strip. If there's any kind of a gap here, you're in trouble. And that would happen if, for example, I tried to install these rivets using a flat-ended hammer only. If I started hitting the rivet down completely with a flat-ended hammer, there wouldn't be a mushroomed end on the top to draw the two pieces down together. Instead, the shank would swell up before the top came down against it, and you'd end up with a gap in here. So this procedure is very important to get good tight fits, because if it's not up against there, it's going to come loose almost immediately. So now we need to tighten up a tooth that is in the center here. Now these center teeth are a little hard to deal with because you've got this blade coupling strip in the way, and I can't just turn this thing over and set it on the anvil like I did with these others. Even using the corner, it's not going to work. I have to find some way to support these things that's going to actually lend them support. So I'm going to grab one more punch out of the toolbox here. Big long thing that's a big, large diameter punch. It's about a 3/8 diameter. Open this up, rest it against the center shank of the vise, give it good support. This is the loose one, so I know this and this rivet are the ones that are loose. I'll turn this thing over, scrape some of the soil off of it, support that rivet just like that. Again, ball into the hammer because I'm tightening a rivet that's already installed. Okay, I'm going to drop it down into that countersink right there. Perfect. Now that one there should probably... This is tight. The rivets aren't too bad on this one, but it's got a nick in the side here, and even though I could just sharpen that nick and make this thing cut, I'm going to take the opportunity here to show how to replace the rivets that are down in one of these countersinks. So I'm going to go ahead and drill this off and take that one out. Rather than making you wait through me drilling this thing out, we'll cut and we'll come back. Go. Okay, we've gone ahead and knocked out one of the offending rivets in this blade coupling strip. And the other one is real hard to get to because it's between here, it's between the blade coupling strip and one of these cleanouts, and I can't support it on either side of the vise. You want to be supported right around the rivet that you're going to drive. So I'm going to take a socket and set it on here and drive down into that socket. So this is where I need my little helper here. There we go. And that's done for. Looks good. Make sure all the old shards of rivet are out of there. All right. Now, I've got the appropriate length rivets, and since only one of these rivets is passing through this blade strip, one of the rivets needs to be the long and one needs to be the short. So, goes down on there. Now for this one, of course, I can go ahead and just use the standard method. I can go ahead and hit it with the ball end of the hammer. Okay, nice. This one is not so simple, obviously. I can't hit it down in that hole. But I have to get that head flaring out on that thing. Otherwise, it's going to do what I described earlier, and the thing isn't going to seat down right. So I'm going to use my tapered punch. This is the center punch I center punched those rivets with earlier to drill them. I'm going to use this thing in the center, and this is going to be my artificial ball peen hammer. I'm going to simply drive this thing down into here. Get a little counterbalancing here. Make sure I've got it centered up well. And this is basically just driving a wedge into that soft rivet steel and just pushing out that head, making it mushroom. A little more. Getting it flared out pretty good there. Now, I can go ahead and take a larger punch, like this one I supported the bar assembly with earlier inside the vise. Again, I'm going to hold this with vice grips because I don't trust myself. I'm going to drop that thing down in there. It fills up pretty much that whole void. Voila. Everything's in good shape. It's drawn up firmly against the bottom. Rivets completely compressed. So that's pretty much it. Next we'll do a Lego segment on sharpening, and we'll do that in a second. Alright, we've got our sickle bar all serviced up here, a couple new sections, all the rivets are tightened up, everything's ready to go, except I want a little better edge on the teeth. These are sharpenable. What I've got here is a 4.5 inch disc grinder. This one's actually equipped with a sanding disc, although the regular grinding wheel is fine. You just have to be conscious that you don't hold it in one place for too long on the tooth or push too hard, because you don't want to turn the metal blue. You don't want to overheat the metal. So you use light pressure and keep the disc moving. So I'm going to wear eye protection like a good boy. Go down the line. Shut it down here just to illustrate some things. Some of these I'm grinding more than others because I see chunks out of them. They're little chips, and where that chip is, if you'll just grind away enough of the blade material, you can get it back to a sharp edge. These blades are serrated on the bottom, that is, they've got little lines. You can see it a little easier on the new one there. And those serrations go in for almost a 1/4 inch. So you can always sharpen the blade material back to where the serrations come out to the end again. This one has hit something. It's got a small notch out of the side. You'll see them with a lot worse. I've seen them with notches almost 3/16 of an inch deep, and you can still kind of grind away enough blade material to get it back to a flat surface on the bottom, and the blade will go ahead and cut. And even if you see a blade tip broken off, if you struck a rock and broken, say, 1/3 of the blade length off, you can sharpen what's left and it'll go ahead and cut. There's enough blade surface left in here that you don't have to replace the tooth. So I'll continue on here. I won't make you watch through this entire process because it gets a little tedious, but you get the idea. You just try to match the factory angle on the blade. If you do use a little too much pressure or get it, the grinder in one place too long, you do get a blue spot on the blade. Don't worry about it. You haven't ruined the blade. Simply lighten up your pressure, keep moving, and you'll actually grind the blued metal off and get down to non-hardened metal beneath it. So this pretty much takes care of blade servicing. The other thing you're going to want to do is sight down the blade after you're done with it. When you beat on a rivets, rivet or rivets in a particular place on the blade, it may actually deform the blade strip and you'll actually have a bowed or bent blade. And those can be straightened out. I have a very slight bow at this end, and frankly, a little too far. Okay, it's a straight blade again. So you can also, when sighting down the blades like this, you can also see if any of the blade tips are bent one way or the other. Sometimes when you run into a hard object like a rock or a post or something, it'll actually kind of buckle the blade, kind of bending it up in the center. I have a couple teeth right in the center here that are slightly pushed up. They must have got something wedged between the lower blade and the upper blade, and they're actually bent a little bit. I'm going to actually keep my eyes on those. They're these two right here. And I'm going to straighten those puppies out. Right there. The steel has a little bit of a memory to it. And even though it's pretty hard steel, and if you try to bend it too far, you'll actually snap the stuff, it'll usually come back to its original shape with a little persuasion. Perfect. You can't tell it from the others. So just some light tapping. If I haul off and just smack the thing, it'll just pop it right off there and go flying across the room. But you can usually tease it back to its original shape. So all the blades are straight. We're going to pretend all the blades are sharp, and then we're going to go ahead and mount it back on the sickle. And we'll just walk through that generally. Now, I haven't taken the time at this point in time to clean everything up, but normally I'm going to clean all this dirt off of here, wash this down, maybe take that wire brush and scrape some of the rust off. For now, we're going to pretend that I've done all that. We're going to reinsert this blade. Away, blade. Probably be a good idea when you're doing servicing on this to go ahead and remove this hood, or at least loosen up this bottom bolt so you can check the nut that secures this blade pin in here. This blade pin is the piece that fits inside the blade coupling, and that pin is driving it back and forth. So that thing is reversing direction about 500 times a minute. There's a lot of force on that thing. It's held in there by a nut kind of on the top of the pitman arm, and that nut should be tightened at least once a year just to make sure that it's not coming loose. That thing takes a lot of abuse. So I'll get this line back up. I will generally oil this. Before I slide this back in, if I had this thing cleaned up completely, I would spray this down with some kind of lubricating oil. We use a product called Fluid Film, which is a lanolin-based product, but you can use just regular motor oil or gear oil or any kind of oil. A thin lubricant like WD-40 is no good because it'll dry up too quickly, but to have some sort of lubricating oil on the blade as you slide it back together, a little on the top of the blade is good too. Slide that back in. Put your blade coupling back on. The blade coupling has these serrated grooves in the bottom of it that fit into the serrated notches on the blade coupling strip. So of course you have to make sure they're lined up. You can see the bolt holes down through there. Bolts back in. Now there are several different styles of blade couplers. Some of the oldest BCS sickle bars actually just had a plastic blade coupler. It was designed as a shear block, so when you got something hard in between the teeth, this thing would break. The problem with the plastic, of course, was that it had a limited service life. They then went to aluminum blade couplers, and in later years they went to steel blade couplers like this one with adjustment bolts in the side. And the adjustment bolts allow you to completely take the slop out between that blade drive pin and the blade coupling. This reduces vibration because you don't get a slap, 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 slap. So, drop this down. Now, this style here that we're seeing here is the latest style of BCS blade coupler. It has the adjustment bolts in it. It is gray or silver in color, and it has lock nuts. These are big jam nuts that actually hold these adjustment bolts in place. So if I wanted to change the adjustment on these bolts, which I should because this has a little too much slop in it. You see that kind of movement there? That is probably about a millimeter of play. That's too much. That's about 40 thousandths. The BCS says you should have about 10 thousandths play in there. So what I'm going to do is grab a couple wrenches. Loosen up one of these jam nuts. That's a 22 millimeter nut. You don't have to adjust both at the same time. You just want to make sure that as you adjust them over the years, you sort of adjust them in evenly. There's plenty of adjustment on both. And I'm going to bring this bolt in a little bit, which is going to tighten down against that blade pin. Now you don't want to completely take all the slop out of it, which is what I've just done. I want to loosen it up just a hair. There has to be some movement there. Otherwise, as the thing heats up and the metal expands, it'll actually bind and cause problems. If you can hear that, you can hear the movement, but you really can't see it. That's about the best way without a feeler gauge to approximate the movement you need. You can hear it, but you can't really see it. That's good. Now I'm going to bring down this lock nut again. Nice. So that's properly adjusted. Now I will say that earlier versions of this style of blade coupler had a slightly different system. The blade couplings were black, and this is how that can be easily identified. They did not have a lock nut. They simply had these bolts and they had adjustment bolts going in the side. The way those were made, these bolts actually clamped down on the lock bolts. Therefore, you had to loosen these up a little in order to adjust I'm sorry, not the lock bolts, but the adjustment bolts. So you loosen these up, adjust your adjustment bolts into the proper tension, and then tighten these back down in order to clamp everything in place so the adjustment bolts don't just vibrate out. Go ahead and check this one more time. For anybody using sickle bar very much, you want to keep an eye on these bolts. These bolts are again transferring all the power through the oscillation of the sickle bar. So these things again are going back and forth about 500 times a minute. And after a couple good days of sickle barring, you should check these bolts. Just put a 13 millimeter socket or wrench on there and make sure the things are tight. They're only threaded into about a 1/4 inch of steel, so there's not much holding power there. So you just have to keep on top of them. A little Loctite is not even a bad idea on them, some of the blue thread locker. So at this point, I would tighten down the clamps, make sure everything moves smoothly. I would have it oiled up completely. Always have it oiled when you're checking the adjustments. You can even, after you've tightened the clamps, you can wiggle the blade up and down. I'll demonstrate that now. Whoops. Get my tools to cooperate here. There's a little up and down play, even after that clamp is fully tightened. There's a little up and down play under there. And I can tell that there's no resistance there, which means this clamp and the top of this blade has worn enough that this thing needs to be adjusted. So I would grab a 13 millimeter wrench, of course. And typically when you're doing this, like I say, you would have everything clean, everything oiled, so everything's, there's no grit. So we're kind of doing a shortcut here for the video, but you can imagine this thing being clean, hopefully. You would loosen this lock nut, which holds the adjustment bolt in place, and you would back this bolt head out, which is flexing this clamp forward and pushing down on the front of it. There's a little more friction now, but not enough. Just go in very small increments here. Well, that's pretty good. That's pretty good. I may be able to tighten it down a little more if I had some oil in there. But the fact is, and you want enough tension on these blades that you get a good scissor action. If you have a pair of scissors that's sharp, but it's loose at its joint, it's not going to cut. It'll just fold a piece of paper over. Same thing with a sickle bar. It can be as sharp as anything in the world, but if those clamps aren't properly adjusted and you've got a big gap between your blades, it'll just fold the grass over. It's not going to slice it off. So you want an action, think of a scissors. You want it just tight enough that you feel that nice shear action, but not so tight that you can't move it. So you can over tighten these things pretty handily and you can't move the blade. So usually when you're going to do the blade adjustment, you start at one clamp and you work your way down, and it should get progressively a little harder to move as you go down. But by the time you get to the end, you should still be able to move it by hand, barely. Properly oiled, you'll usually have to do this kind of thing to get it to move back and forth. You won't just be able to do what I'm doing here. It'll be a slap, 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 and that's about all you can do to move it, and that's fine, that's perfect. But if you get to the end and you think everything's tight and you cannot move that thing by hand, it's too tight. Go back across it and loosen up everything a little bit. That pretty much concludes our sickle bar segment. Thanks.